Are you developing an AI application using libraries like LangChain or tools like Tasking AI for yourself or your clients? Are you struggling to bridge the gap between a solution that works 95% of the time and one that works flawlessly? If so, this video is for you. Hey friends, and welcome back to the channel. I'm Donna, an AI specialist based in Sydney, and today we are diving into 4 essential strategies that will elevate your AI application's performance from good to exceptional. Whether your application is delivering inconsistent quality, making frequent errors, or generating hallucinated responses, these strategies will guide you towards achieving consistent and high-quality outcomes. I will break down each strategy, explaining its core concepts and how it can be applied effectively. We will also discuss when and where each strategy is most applicable based on different AI applications and use cases. And finally, I will share tips and best practices to help you maximize the effectiveness of these strategies and achieve the results you're aiming for. By the end of this video, you will have all the secrets I am using with my clients to maximize the results we are getting and a clear roadmap to refine your AI application and ensure it performs at its best every single time. Let's get started. The first strategy to use to maximize the results of your AI application is evaluating the current results you're getting. For that, there are a lot of libraries that you can use. The one that I recommend, as it's the simplest one to use, is called Langsmith. Note that Langsmith can be run without LangChain, as it is a separate library. The easiest thing to start with is adding a trace. A trace is a series of steps that your application takes to go from an input to an output. If you have multiple chains or call to the LLM, it will be logged as one trace. For example, a call to the LLM to generate something and the use of an output parser to return the result. A trace can be added by a simple annotation, which is @traceable, before any Python function. This is how it will look like in Langsmith. On the left, you will see the different chain and calls, and on the right, the input and output of each request. You will also see the status, date, total token spent, and latency. You can even see the model used. Having trace is a good start, but you will also want to do evaluations. Evaluations allow you to understand the performance of your LLM application over time. For that, you will need an example, and an example defines the input over which you run your chain, model, or task. You can also add an expected output of the task, which is not mandatory, and we will see later why. Here I have 2 examples. The first one is a simple question: what's the capital of France? And an expected output, Paris. Second example is simply country France in a JSON format. Once I have this example, I can use an evaluator. An evaluator is a function that takes as parameter an example and also the actual output and returns a score. We will see later what type of evaluator you can create. So the first step to evaluating our current result is to create a dataset, which is a collection of examples. The second step is to add existing evaluators or implement your own. You will pass that dataset and also the output you're getting from it to the evaluator that will return a score. Now let's see what type of evaluators you can use, and there are 3 types. The first type is heuristics, which is a hard-coded function. For example, a function to check if the JSON return is valid or not. It could also check if the response is matching 100% with something. In our case, it could check if the response is an exact string, like Paris, returning 1 if that's the case and 0 if it's not. So even if the result is the capital of France is Paris, it will return 0. And that's where our second type of evaluator comes into place, LLM as judge. That type of evaluator will use an LLM to judge. For example, you could check the accurateness of the response or the tone. Now, whether it returned Paris, the capital of France is Paris, that is still correct, and that will still return 1 as a score. Finally, the third one is human, and for that one, you will be using the Langsmith SDK or interface and add a score yourself. The last step for evaluation will be to analyze the results and figuring out problems in your application. You will pay attention to which output are not working and use the other 3 strategies to solve the issue. For that, you can go to the trace, and on the feedback tab, you will be able to find all of the scores that you added. As a recap, the first step is to create a dataset, then add evaluators, either from the library or implementing your own, and then analyze the results to figure out problems in your application. The advantages are that it is the first step before trying to do any other improvements, as it allows you to compare the expected output with the actual output. This is also crucial to avoid worsening your results when using other strategies. How would you know that you are moving closer towards your goal without any evaluations or benchmarks? The limit of evaluations is that it can be costly, especially for LLM as judge evaluators, if you don't pay attention, as it will send an additional prompt, but evaluations can be disabled or reduced by changing parameters in the environment variables. Before jumping into the next strategy, if you like this type of content, please leave a thumb up and subscribe to the channel. I will be releasing more and more videos diving into each of these strategies. Now, let's jump into the next strategy, which is, without surprise, prompt engineering. I know you might think that I am stating the obvious here, but your prompt impacts a lot the result you're getting. So let's get some reminders and see if you have the best optimized prompt. A good prompt contains a role or persona, a task, a list of specifications, a context, and some examples. Here we could have a single prompt that is, write a blog post about the importance of eating breakfast. But this will work much better. Here we add the role, task with more details telling it what to do exactly, even the length of the blog post, the tone, the target audience, a structure, a context, and an example, and the return result will be much closer to what we want. Some other tips can include writing clear instructions, do not use complex tasks, and splitting them into simple subtasks with clear methodology like step 1, step 2, step 3, etc. Adding sentences like approach this task step by step, take your time and do not skip steps, and also using markdowns help a lot to improve the results I'm getting with my clients. You can also find some more tips on the OpenAI documentation. The advantages are that you can quickly improve your results if the previous prompting strategy you were using was not ideal, and it provides a baseline for further optimization. The limits of it is that you cannot use that to add new dynamic information to the LLM related to the query, and you cannot use that to make the LLM learn a new domain. Meaning, if you have company documents, you cannot simply paste them into the prompt. Now that your prompts are longer, you also just increased the token usage for each and single request. Finally, it is not good to replicate a specific style of response, even when provided with a lot of examples. Providing too many examples could actually make the LLM confused. If you want to replicate a specific style of response, I would turn into fine-tuning, which we will talk about later in this video. Going back to your prompt in your AI application, have you tried using these tips and tricks? If not, I would highly recommend you to fix that first, as it is the easiest to change. If you already knew about it and already applied it, then I recommend you to stay on this video to see what else you can do. The next strategy to use is RAG, which stands for Retrieved Augmented Generation. It is used when your model needs specific information to answer a specific question or task. For example, if you want to ask questions about your own company documents, it will add the retrieved information to the context area of your prompt. So this will be the new structure of your prompt, where you have an enhanced context with specific additional data related to your query. I made a specific video diving deeper into how RAG works, and I highly recommend you to watch that video if you want to understand how RAG actually works under the hood. But let's briefly go through how RAG works in this video. In a nutshell, you upload a list of documents that are going to be divided into chunks and stored inside a vector database. Then, during the retrieval phase, it will do some similarity search in the vector database to find out the chunks that are the most similar to your query and return them. These chunks will then be added to the prompt in the context section. The advantages of RAG is that it is adding more relevant context to your prompt. You can then easily reduce the hallucinations by telling it to only respond based on the chunks provided. The last advantage is that it is not too hard to implement with libraries like Langsmith. Now, the limits of RAG is that it is used only for short-term memory, as it won't be saved anywhere and only used for that specific request. Also, it will increase token usage for each request as we are adding the content of the chunks. There are some libraries like Langsmith or Ragas that allows you to evaluate the accurateness and relevancy of the LLM, answering the question which we did in part 1. the quality of the chunks retrieved related to the question, the context precision and context recall can also be evaluated with a library like Ragas. The last strategy to use is fine-tuning. Fine-tuning seems like an obscure and complex topic, but I promise it is not when you understand its core concepts. So, what is fine-tuning? On the YouTube video from OpenAI called A Survey of Technique for Maximizing LLM Performance, they make it easy to understand. They say that fine-tuning is continuing the training process on a smaller, domain-specific dataset to optimize a model for a specific task. So, for example, it could be extracting specific properties from a real estate advertisement and transform that into a JSON object. And to understand better fine-tuning, we need to talk about the loss function. Loss function is a method of evaluating how well your algorithm models your dataset. So how well the model predicts and creates the output you desire. In this case, the green boxes represents the outputs and the line the expected outputs. As you can guess, the higher the number, the furthest the output is from the expected output. Fine-tuning is all about reducing as much as possible that number there, reducing as much as possible the loss function output. Now let's see how to fine-tune a model. The first step is to create a dataset, so a collection of high-quality data, both inputs and outputs. You will be going through collection, validation, and formatting. The dataset also needs to have diversity to provide even better results. There are different ways to have a good dataset. The first way is to use your own data, curate and format it. You could also pay someone to do that with your own data to be sure the quality is optimal. You could also download an open source dataset from Kaggle, for example, or buy one. Finally, you can use an LLM to generate the dataset. Once you have your dataset, you can go on the second step, which is the training process. And there you have two possibilities. Fine-tuning using a famous LLM like the OpenAI one, or fine-tuning locally or on the cloud an open source model. For the latter, you will require your own resources, GPU, CPU, etc. I also highly recommend to use tools like Anthos to accelerate the process. In this video, we will dive deeper into the first option with OpenAI SDK, as it's good enough and less complicated than the latter one. And the first step is to upload the training file, so your dataset, from a JSON-L file. Then you will start a fine-tuning job with the following lines. And there you have the training files, the model, and some hyperparameter. You can omit the hyperparameters fields for now, but I wanted to give you an idea of what option you have. So let's dive into that now. And we'll take a simple analogy here. Imagine that you're studying for an exam. The first one is the number of epochs, and it's the number of time your entire dataset is passed through the model during training. Coming back to our analogy, each epoch is you reviewing your studying notes once. You will want to increase it if the model is not learning well enough, like you studying more if you didn't grasp the material. You will want to decrease it if the model starts to overfit or become less diverse. Kind of like if you studied too much and lost any creativity in the response for a field like philosophy or literature and spitting out the exact same thing as in your lesson in your exam. The next one is learning rate. The learning rate controls how much the model's parameters are adjusted during each step of the training process. It's like deciding by how much you turn the knob to optimize the parameters. The learning rate multiplier is a factor that scales the base learning rate. This is like setting up how much you would learn from each review of all of your notes. At the beginning, you will want to increase it a lot, and later on reduce it to make gradual refinement. For the adjustment tips, I would advise you to increase it when the model makes very small updates and you want the model to make bigger leaps towards the optimal goal. I would decrease it when you want to make gradual refinement, smaller and more precise updates to the response. The last one is the batch size, which is the number of training samples used to update the model at once. For the adjustment, I advise you to start with a default value and adjust based on memory constraints and performance needs. Larger batch size can make the training faster and more stable, but it also requires more memory. And that's it for the most common hyperparameters. Once you start the fine-tuning job and the fine-tuning is finished, the third step is the evaluation. To see if you are moving closer to your expected output, using the evaluators created in step 1 and seeing if the loss function value is going down. I wanted to leave you with some tips for fine-tuning. The first tip is to start small and focus on high-quality datasets than quantity. You are better off with 20 good examples rather than 500 bad ones. And the reason being that bad examples will optimize for the wrong outputs. The second tip I have for you is to have an active learning approach, where you first look at the results you are getting, look at what's not working, create a dataset that specifically targets these areas, and then fine-tune the model. You will repeat that active learning approach as much as possible until you get the perfect results. The advantages are that it is good to replicate a specific style of response, specific format, tone, etc., as you can give it examples and it adapts pretty fast to it. It is also good for teaching a model how to handle very complex sets of instructions, and it reduces the tokens needed to do a specific task, as you can remove some instructions from the prompt without losing the structure you fine-tune the model on. The limits are that it can be a bit tricky and complex to apprehend at the beginning. It is also not cheap and quite costly. That's also why you should start small with a few examples to get your head around it. The second one is that it's not good for adding new knowledge to the model. Fine-tuning teaches behavior, not knowledge. Knowledge is added to an LLM during the pre-training phase, and your best approach to add knowledge to the LLM, like company knowledge, is to use something like RAG that we've just seen before. You might think that you need to choose between RAG or fine-tuning, but to get the best results, you sometimes need to use both. RAG allows you to bring more knowledge into the prompt, while fine-tuning helps to make the LLM more specialized into a specific domain. If you think about building an AI application to manage low cases, for example, using RAG would be like returning the most similar low case from a vast array of low cases that matches with the one in the prompt. Fine-tuning would be about specializing the LLM in law, enabling it to return better results in that domain by training it on a large corpus of legal text. To conclude, the different strategies to maximize the result of your AI applications are first evaluating the current results to figure out where are the issues and areas of improvement, then going back to the prompt and doing some optimization. Finally, using RAG to add more inner knowledge into the context, and fine-tuning to continue the training process on a smaller, domain-specific dataset to optimize the model for a specific task. If you like this type of content, please leave a thumb up and subscribe to the channel. Let me know in the comment if you have any questions. Thanks for watching and see you in the next video.